We are finally good to go. Okay, so here's the thing. This book publisher does all of trigonometry in one section when it should really be like a chapter. It's way too much. So instead of doing it in one section in one day, which is bananas, what I've done is I have divided 9.7 into 9.7a, 9.7b, 9.7c, and 9.7d. So today we are just going to do A. We're just going to do the setup, which means that it's not going to really make sense in context yet, but we're just going to do the pre-work. And then when we have notes in a couple of days, then we're going to kind of make more sense of that. So today's just going to be kind of the setting up. We're going to do a lot of vocabulary work and setting up today. But this is all about trigonometry. So here's your trig intro in case you're like interested in, maybe you want to take that class someday. I don't know. Who knows? All right. So there are three main trigonometric functions used for right triangles. They are called sine, cosine, and tangent. Sine, cosine, and tangent. New words for you, most likely. All right. We're going to start off with going over some vocabulary. So sine, cosine, and tangent can be used, in this case, we're going to use them in right triangles to find missing sides and missing angles. But before we get into that, we're going to talk about some vocabulary. So we are going to only be working in right triangles for 9.7. And we are going to get to describe and define where's the hypotenuse, where's the opposite leg, where's the adjacent leg. Now, hypotenuse we've talked about before. The hypotenuse is always the side across from the right angle, right? When we're practicing Pythagorean theorem, we go to the right angle, we go to the side across from it. This is the hypotenuse. All right. In addition, the other sides of a right triangle are called legs. Depending on where my perspective is, in this case of like this little yellow angle here, we'll talk about what theta means in a minute. Depending on my perspective, opposite is going to be across the triangle. So if I'm like standing where this angle symbol is, you can kind of imagine a person is standing here. And if I'm looking across the triangle as if it were a lake, I'm looking all the way across, then this side right here is the opposite leg. And adjacent means next to. Like my classroom, H105, is adjacent to Mrs. Zeeb's classroom, H104. They're right next to each other. And so when we're looking at the adjacent leg is going to be the leg that touches the angle. It's like really close. All right. So this symbol here on my diagram is called theta. It is a Greek letter. And you might see it written like the way that it's kind of typed here, where it is more like straight across, or you might see it where it's a little bit more like swirly, like more italicized looking, but they mean the same thing. It's a Greek letter, and theta is going to always be an acute angle for our circumstances. Acute angle, right? An acute angle is an angle between 0 and 90 degrees. And I can only take the sine, cosine, and tangent of an acute angle. So I will never take the sine of something that's 90 degrees or bigger. Okay? Theta, this angle is always going to be between 0 and 90 degrees. It's always going to be acute. Now, here's my silly example. But we have an abbreviation for Mrs., right? So like, I am Mrs. Thompson, but nobody ever writes out Mrs. We use an abbreviation. But even though we use an abbreviation, MRS, we still say it's Mrs., right? We don't say MERS. That would be different. Okay, so same thing here. So I have abbreviations for sine, cosine, and tangent, but I'm going to use the original name and not use the abbreviation when I'm talking about it. So the abbreviation for sine is SIN, but we call it sine. We don't call it sin. The abbreviation for cosine is COS, but we call it cosine. We don't call it cos. And the abbreviation for tangent is TAN. We call it tangent. We don't call it tan. Now, each one of these functions is a different ratio. It's a different equation to set it up. And I could just ask you to memorize all of these. But instead, I'm going to give you a memory device. And if you were to ask, like an adult in your life, and said, did you ever take geometry in high school? Maybe they say yes, maybe they say no. And if they say yes, you say, do you remember anything from that class? They might tell you SOHCAHTOA. They probably can't tell you what it means, but like that word tends to stick with people. And you get to learn about it today. SOHCAHTOA. SOHCAHTOA. SOHCAHTOA is a memory device that helps me remember how to set up these functions, because the sine of theta is equal to the opposite leg divided by the hypotenuse. The cosine of theta is equal to the adjacent leg divided by the hypotenuse, and the tangent of theta is equal to the opposite leg divided by the adjacent leg. So, yes. So we're going to use this memory device, and I'm going to write it out here. So you will need to learn how to spell it, SOH, so, where S stands for the sine. The sine of an angle is equal to the opposite leg divided by the hypotenuse. So is SOH, so. Ka. The ka portion stands for the cosine of an angle is equal to the adjacent leg divided by the hypotenuse. And the tangent of an angle the TOA part is going to be the tangent of an angle is equal to the opposite leg over the adjacent leg. So this SOHCAHTOA is just a way to remember all three of these equations. So in the tops of a lot of people's papers, you're going to see SOHCAHTOA written as a way to help us set these up. A lot of times I'll write in different colors, but you totally don't have to. It's just helpful for me. SOHCAHTOA. All right. And we're going to take a look at our first example. Example 1, find the value of each trigonometric ratio. I like saying that word, trigonometric. Like it rolls off the tongue nice. Trig is short for trigonometric. 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 All right. I have not always been in this classroom, but I've been here for a long time. Over a decade. All right. Okay, so the first example asked me to find sine of A, cosine of A, and tangent of A. Of A is my perspective. That's what angle I'm standing at. And so I am going to choose to draw a silly little person here. Maybe you draw a happy face. Maybe you just put an angle mark. Maybe you draw a circle around A. Whatever it is so that you feel like you're standing at that. That's your point of perspective. the sine of A. Now, we just said that the sine of A is equal to the opposite leg divided by the hypotenuse. But I need to go through and I need to name all the things in the triangle. So once I figured out where I'm standing, I'm going to name the opposite leg, the hypotenuse, and the adjacent leg. My tip for you is to always name the hypotenuse first because it never changes. The hypotenuse is defined as the side across from the right angle. That's always going to be the same. I have a right angle C right here. I go across from this. And that means that my hypotenuse is 26. I'm just going to use abbreviation here, HYP, because we're going to write these a lot of times. Okay, the other two are legs. Which one's opposite? Which one's adjacent? From A, if I look across the triangle, opposite the triangle, that's going to be over here for 24. 24 is opposite. Adjacent means next to. So the adjacent leg is going to touch the angle. Right now I'm just naming these three titles. Just naming them. Yep. So the adjacent leg is going to be the leg that touches that angle. So once I've done my naming, I can set up my ratio. Sine of A is equal to the opposite leg. Well, I just named that 24. Divided by the hypotenuse, which I named 26. And that's it. You've set up your first trig function. Okay. I know we're not solving today. We're not going to get into that, but we set one up. There we go. Right? So cosine of A. Cosine is equal to the adjacent leg divided by the hypotenuse. So from where I'm standing, adjacent we said was 10. So cosine of A is equal to 10 divided by the hypotenuse is still 26. All right, and then the tangent. The tangent of A is equal to, make sure you've got an equal sign in there. It is an equation. The opposite leg divided by the adjacent. So TOA stands for opposite over adjacent. My opposite is 24. My adjacent is 10. Woohoo! All right, we did one. Any questions on example one yet? Bless you. Bless you. All right, so the next picture, I have new values on my sides, and I am asked for the sine, cosine, and tangent of y, and then the sine, cosine, and tangent of x. Every time I go to a new angle, I'll have to rename my opposite and my adjacent sides. So I want to do all the y's first before I go to a different value. So I'm going to start at angle y. All right, here I am. I'm at y. That's where I'm starting. And before I start, oh, it's lagging. Before I start doing my sine, cosine, and tangent, I'm going to name all of those sides. Right? If we can't name the sides correctly, the rest is going to fall apart. So that's why we're taking baby steps. The hypotenuse. I recommend you always name the hypotenuse first. Across the 90-degree angle is the hypotenuse, so it's going to be 32. If you don't name the hypotenuse first, then when it comes to looking for the adjacent leg, you might be tempted to say that it's 32, but 32 is not a leg, it's a hypotenuse. Opposite is going to be whatever's across from the triangle. So you have to look all the way across. So opposite is going to be 28. And then 24 is the leg that is next to where I'm standing. So it will be adjacent. All right, so SOHCAHTOA. First, ask for the sine of y. The sine is represented in the SO by the opposite over hypotenuse. So the sine of y. Let's see, I just said that the opposite was called 28. And the hypotenuse is 32. We go to set up the cosine of y. I'm at the same angle, so my little person doesn't move. Still at y. Cosine is the ka part of SOHCAHTOA. So cosine is equal to the adjacent divided by the hypotenuse. Adjacent is 24. Hypotenuse is 32. And then tangent will be represented by the TOA. Tangent of an angle is equal to the opposite divided by the adjacent legs. So we named the opposite 28 and the adjacent 24. Now, the next three questions asks for sine of x, cosine of x, and tangent of x. I changed my angle, so I have to change my perspective, which means I'm going to have to rename some things. Because the name of the hypotenuse is based off of the right angle and not where I'm standing, I can leave my hypotenuse tag, but I'm going to have to move my other ones. Because now, I am at angle x. That's me, long hair. Extra long neck. My stick people always have weirdly long necks. Okay, so now that I've moved my perspective, now my opposite leg and my adjacent leg are different. So from here, I still have hypotenuse is still 32, but now the opposite leg is going to be 24. And the adjacent is 28. They've switched. I would like you to please go ahead and find the sine of x, the cosine of x, and the tangent of x. Ready, go.
Did I check my phone? No. That's how long you do that.
On your own, you can probably try.
No, I'm not. You know no, it's not right. No,
Let's see it, let's go. Let's see it, let's go. You're only going to learn this stuff. Put in a little effort.
I think I got it.
Never been to.
And you have still missing work.
Hey, when did you think you were? Well, I have a. That's not even until Friday. Once Friday happened, after I got out of the camp, went to national race. That's just crazy. I don't like burgers. Sorry, I like burgers.
Okay. I would like you to, let's see, does everybody have a partner today? Oh, no, not everybody. Brianna and Ava, you're missing your partner, so if you guys could turn around and be partners, that would be awesome. And Jameson, you don't have a partner, but if you just make like a team of 3 over there, that would be great. Okay, with whoever your partner is, please have a conversation. Where would you love to go on vacation? Where do you want to go on vacation? Go. 60 seconds.
I would love to go. I want to go on a trip. I would love to go to Australia. Bro. Where do you want to go on vacation? Can I grab my phone?
Where do you want to go? Where are the good vacations happening right now? Malaysia. Oh, why not? I could really go for some tropical vacation right now. I haven't been on one in a long time. But I think if I had to choose, my husband was stationed in Germany back in the day when he was in the army. And so I've always wanted to go there with him and like, you know, I mean, I've been to Germany, but we haven't been together. With a friend. I went backpacking when I was in college. I do have some roots in Germany. Okay, now I would like you to talk to your partner, and I would like you to compare answers for G, H, and I.
I got. That's what I got. You didn't even do it. Why shooting or what? See, there's an odd. It wasn't that hard. I got.
Jake, Nura, have a conversation. Compare your answers. Christian, Chris, compare your answers. Let's go.
I got. I got all that. Did you just copy like? No, I got 24. I got 24 over 32. I figured it out. 24 over 32. And that's for the co-eds. What time do we get out of class? I got
12:47. All right. All right. One more part to this, and then I'm going to let you get your phones out. So one more part. Hold on. Okay. Last part. Here are the answers. Please discuss with a partner, and I'm going to call on people who look like they're not talking to their partner. Okay. Please discuss with a partner, what are some observations you see about, look, I've got sine, cosine, tangent of y, and sine, cosine, tangent of x. What are some like noticings you have? What are some patterns you have? Talk about it with a partner, and then I'm going to call on some people. Go. Are you talking to your partner? You're not talking to me. Oh, okay. You guys talking? What? Oh, just because the internet won't run. Oh, Cindy, it said it loaded. Okay. Okay, you've noticed some things.
There was a
I know some
position
things.
online that I found
It's
that
not-
was showing people, like from like 2019 of her trying to get by it. This is long.
Stops it.
All right, you have a noticing? What? Oh, well, no, because I was going to call people who looked like they weren't talking.
I got something nice.
Yeah. You have something anyways?
Yeah.
Okay, Jameson is excited to share. What did you
I would
notice?
like some gummies though.
Cool. I'll ask someone else.
Alright, I noticed the sign and the adjacent, they just like flip flop.
Sign of Y and
Like they just flip flop. Like 24 and 28. Oh no, I'd say on the hypotenuse.
okay. Maybe you're onto something and I'm not understanding it very well. They just switched. What part switched? I know what happens, but I want you to use your vocabulary to explain to me what happens.
Sine of Y, it's sine of X. Okay?
Sam, do you want to pick up where you left off?
You
You have a different one. Okay, what's your different one?
Oh, in both equations, the denominator stays the same for sine.
Oh, good. So for sine and cosine, no matter where I'm at, the denominator just stays 32 as the hypotenuse always. Great observation. Cool. Do you have another one? Nora, would you share with me an observation that you and Jake had? Beautiful. Tangent y and tangent x flip the numerator and the denominator, right? One is the reciprocal of the other. Yes, they just go boop like that. Awesome. Yeah, the reciprocals. Okay, there's one more thing that I'm looking for. Does anybody see another observation? Maybe where the fractions are the same? What do you see, Jaden?
Y and X is in.
Be more specific.
Oh yeah. Yeah.
Okay, go ahead, Sam.
Sine Y is the same as cosine.
Yes.
Yeah, they just
Sine of y is the same as cosine of x, and then vice versa, right? Sine of x is the same as cosine of y. That's because sine is just opposite of a hypotenuse. But if I switch where the opposite and the hypotenuse are, now I have the same thing as the cosine of the complementary angle. Okay, cool. I am going to give you a 2-minute brain break to get out your phones, check your messages, and then we'll resume. So because the internet is having a hard time uploading, my notes are not the latest version. And they're the latest version on one computer, but not on this device because of some connectivity issues. So I have this question on the bottom, food for thought, but yours is on the right-hand side right here. It says, food for thought, why didn't we use the trig function from angle Z? So let's go back and finish this up before you turn the paper over. Your question is just to the right here, which is where I wanted it, but this is my old version. Food for thought, why didn't we use the trig function from angle Z? Anybody have any? I mean, I did sine, cosine, and tangent from Y and from X. How come I didn't do it from Z too? What have you got, Isaiah? It's not acute. Was that the same thing you were going to say? Yes, that's correct. It's acute. It's a right angle, and it doesn't fit my criteria. It can only take sine, cosine, and tangent of acute angles. So why didn't we use the trig function from angle Z? Angle Z is a right angle, not acute. Perfect. All right, so when you turn it over to the next side, yours has additional directions, which this one should have. I'm sorry? Yes. Yours already says this. Find the sine, cosine, and tangent of angle G. Write answers as fractions and decimals. I'm going to add a note. We're going to round decimals to 3 places. We're going to round decimals to 3 decimal places. So maybe add that note. So we're going to find the sine of G. We're going to find the cosine of G. And we're going to find the tangent of G. Before we do any of that, would you please go to this triangle and name where is the hypotenuse, where is the opposite leg, and where is the adjacent leg. From angle G, I'm standing at angle G, that's my perspective. The first thing is if we cannot name these sides correctly, the rest of it's not going to work out for us. Turn back in. We're on the other side. So on that triangle, please, I want to walk around and see everybody has written the hypotenuse, the opposite, and the adjacent on that triangle. And you can use abbreviations. You could use just the first letter. I've lost you now.
I threw a Molotov in that.
Good. If you're at angle G, then opposite has to be across. So this is actually going to be opposite, and that's going to be adjacent. Okay, so from angle G, opposite means across. So you want to go all the way across the triangle. That's the opposite, which means that's the adjacent. Okay. The hypotenuse has to be across from the 90-degree angle. Across from 90 degrees needs to be the hypotenuse. I can't believe you're actually watching a show while we're doing notes. Good. Hypotenuse is in the right spot. Keep going. Mm-hmm. I asked you to name the hypotenuse, the adjacent, and the opposite in this triangle.
Wait, what?
I asked you to name the opposite, the adjacent, and the hypotenuse in this triangle.
Got that.
I asked you to name the opposite, the adjacent, and the hypotenuse in this triangle. Everybody should have written where they think the hypotenuse, the opposite, and the adjacent is in this triangle. It is crucial. If you cannot name these correctly, the next 2 weeks is not going to work out for you. This is like building blocks. We got to get this part right. All right. Hypotenuse is going to be 8. It is across from the right angle. So I go to the right angle. I go to the longest side in the triangle across from it. That's the hypotenuse. The adjacent and the opposite are relative to where I'm standing because those can change. So if I'm standing at G, opposite is going to be all the way across. It's going to be the furthest leg. So the opposite leg is going to be 4, and the adjacent leg is going to be 4 radical 3. I am going to do cosine of G for you. And then I'm going to ask you to do the sine of G and the tangent of G. And this is where our calculator work comes in. The cosine of G. All right, cosine. Cosine is the adjacent divided by the hypotenuse. So cosine, I want my adjacent side, which is 4 radical 3, divided by my hypotenuse, which is 8. The directions ask me to write answers as fractions and decimals. So you need your handy dandy calculator to do that. Here's a warning for you. Look, I'm an iPhone fan, had them for ever and ever and ever. The scientific calculator on the iPhone is garbage. It's terrible, all right? You do never, ever, ever do you want to use a single line scientific calculator if you can get away from it. So please, 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 this is where I ask you to use a multi-line scientific calculator. Bring one from home. You're going to need it the next couple of weeks, okay? Because when I plug this in, I want to do as much of it as once as I can. And so in your calculator, you need to find 4 square root of 3. And then if you have the fraction bar button, you can plug all of it in like it is stated right there, 4 radical 3 all divided by 8. Otherwise, you need to include some parentheses and then divide by 8. Or you can do 4 radical 3, enter, and then divide by 8. You also need to find the square root button, okay? On most of the calculators, you're going to have a button that has an x squared, and written above it is the square root symbol. You'll need to press the shift button or the second button to activate what's written above a button. So before you move on, I want you to make sure, before you do sine and tangent, I want you to make sure that you can correctly calculate on your calculator that 4 square root of 3 divided by 8 should be 0.866. So you're going to use your calculator to verify that you get this answer. And then once you figure out how to use your calculator, please go ahead and find the sine of G and the tangent of G. And I'll walk around and see if anybody needs any calculator help. All right. Hopefully we worked out some of those calculator issues. The sine of G should be 4 over 8, which the decimal should be 0.5. And then the tangent of G should be 4 over 4 radical 3. And the decimal should be 0.577. Now remember, I'm rounding to 3 decimal places. So if that 4th place is 5 or higher, then I would round up. Okay. And this is actually where we're going to stop today. We're going to do the rest tomorrow. So hold on just a second, and I'm going to get out your assignment to you. Okay, so continuing with the notes. Use triangle ABC to write a trigonometric expression for the ratio 3 over 4. So now I'm still doing trig functions, but now I'm working a little bit backwards, and I want to write something for 3 over 4. So you can kind of work with this how you will. I do have a symbol here at angle A, which tells me that that's going to be where I'm standing. All right. That's a very funky looking person. Let's try that again. All right. All right, great. And so I want to write a trig expression to represent 3 over 4. So what is 3? Across from angle A, this is going to be identified as my opposite leg, and then 4 is going to be identified as my adjacent leg. And when I review, so ka tawa, I'm looking for something that uses opposite and adjacent. Well, it's not sine. It's not cosine, but tangent does use opposite over adjacent. So let's give it a try. So the tangent of angle A is equal to, opposite comes first, so that's on top, that's my numerator, divided by the adjacent, which is 4. Okay, I did it. It matches. That's what I wanted. And so we're just working a little bit backwards to find out which trig ratio gives me that fraction. And it's the same work for problem B. write a trigonometric expression for the ratio 3/5. All right, well, I didn't identify 5 before. That's the hypotenuse. So now I want to use 3 as the opposite and 5 as the hypotenuse. So I'm looking through SOHCAHTOA to figure out which one uses opposite and hypotenuse. And that's going to be sine. So the sine of A is equal to 3/5. Now, because of our conversations on when we were looking at patterns, I also know that the cosine of B is going to give me that same angle, or that same ratio. And so you can make the argument that the cosine of B would be true as well. And the next one is set up to be multiple choice. Use triangle XYZ, which trigonometric expression is correct for the ratio 5/13. So what I'm going to do is I'm going to go through and I'm going to find every single one of these, A, B, C, D, E, and then just choose the ones that are 5/13. Tip from the pro is that if I'm going to start with sine of Y, I will go through and do all of my trig functions from Y first so that I don't have to keep moving my sides and renaming them. So if I am at Y, across from across from the right angle is my hypotenuse. Across from where I'm standing, 24 is going to be the opposite. It's going to be opposite me, like I'm looking across to it. And then the adjacent leg is going to be 10. So sine, I'm going to write these kind of, let's see. Sine of Y is equal to the opposite, which is 24, over the hypotenuse, which is 26. That's not 5/13. But then you might be asking yourself, well, what is 5/13? None of those numbers are on my triangle. Well, what they've done here is they've reduced. So I'm going to go through and I'm going to reduce all of these answers as well because that's equivalent. Let's see. 2 goes into 24 12 times. 2 goes into here 3 times. Still not 5/13, so that's not a possible answer. I'm going to go through and I'm going to do this other Y1 next so that I don't have to rename. So cosine of Y is equal to, cosine is the adjacent over hypotenuse, so 10/26. And when I reduce that, 2 goes into 10 5 times, 2 goes into 26 13 times. Ooh, I get 5/13. Okay, so this is a possible answer. Let's see if any of the other ones work. All right, let's try for the tangent of Z. So now if I move my person to angle Z, then I'm going to rename right now I'm at Z. I'm going to rename because now the opposite leg is 10. The hypotenuse is still the same. I shouldn't have erased that one. That was silly, but there it is. And the adjacent is 24. So the tangent of Z, tangent is OA, so opposite over adjacent. 2 goes into 10 5 times. 2 goes into 24 12 times. That's 5/12, not 5/13. Let's try cosine of Z. So so adjacent over hypotenuse. Reduce. That one doesn't work. Well, maybe there's only one answer, but let's check sine of X. Now, if I look at sine of x, x is the 90-degree angle. I cannot take the sine of x, the cosine of x, the tangent of x, any of it, because x is the right angle. And I can only take sine, cosine, and tangent of an acute angle. And so this one doesn't even exist. And so I've eliminated everything else. My final answer is just d cosine of y. Okay, so that sums up 9.7a. And in the next section, we will learn how to solve for a missing side. All right, thank you very much.